Hello again. So, we have a little bit of a new concept to talk about. So, previously we have been connecting the vertices to the midpoints. Those are the medians. But we can also connect the midpoints with each other. That's what we have in figure 7.3. Triangle DEF. And when we connect the midpoints, we call that a medial triangle. So DEF is the medial triangle of ABC because it's connected with all of the midpoints. Now, what is so interesting about a medial triangle? Well, let's try looking at it out. So, 7.19. Prove that the four small triangles in figure 7.3 are congruent and that each is similar to triangle ABC. So let's start with, what do we know? I know that, we have all the congruent sides labeled. Is there anything else that we could work with? Well, I know that I think it would be very easy to prove similarity right off the bat. For example, let's look at triangle CED. And then compare that to triangle CAB. So, I notice that they both share this angle of C. So, I'm just going to say that angle C is congruent to angle C. What else? Well, if we're comparing, let's say CE has a length of x. And that means AE has a length of x. And then let's say CD has a length of y. And then DB must also have a length of y. And if I'm trying to compare ABC to EDC, well, let's match the sides up. So let's say start with side AC. What side does that match with? Well, it matches with CE. And if I can prove that that's proportionate with CB over CD, that would show similarity. Well, AC has a length of 2x and CE has a length of x. Compare that to CB, which has a length of 2y, and we have that CD has a length of y, which means that those cancel out and we're left with 2 equals 2, a perfect proportion, which means that triangle CED is similar to triangle CAB, and what we just used was side angle side. So, wonderful. Now, if those two triangles are similar, then that means that this angle here is the same as this one. And this angle here is the same as this angle here. That means parallel lines. AB must be parallel to ED. Okay, interesting. Now, if that is true, then what that implies is that, it's pretty easy to determine some of the rest of the proofs. So let's say that, I labeled all this so I can say that this is Z and this is Z here. And it would be fairly simple to show that, we have triangle D, F, B. That would have to be similar to triangle. Well, DFB D to F. No, yeah, D to F to B would be the same as saying triangle. Let's see. D F. Oh, CAB. Yeah, easy. CAB. Because it's side angle side again. And similarly, you can show with the same logic that we used for the first part that triangle A, E, F is similar to triangle AEF is ACB. Side angle side. Alright. Now, with all that figured out, we can come up with all the congruent angles. So, we know that so AEF, so this one would have to be C. And that means this one is the one with 2 tick marks. And if that's true, then we have DFB, DFB, CA, so that's the 1 tick mark one, and that's just the blank one. Okay. Now, so we have shown all the similarity. Now let's try to show some congruence. Are the 4 small triangles in figure 7.3 congruent? Well, if all the angles of a triangle add up to 180, so we have the no tick mark plus 1 tick mark plus 2 equals 180. Straight lines also add up to 180. And this angle from here to here to here is a straight line. That means this one has to have 2 tick marks to get the 180. This one has to have no tick marks to get 2 plus 1 plus 0 tick marks to get the 180. And that means this one here has to have 3 tick marks. Well, is that the 3 tick? No, just the 1 tick mark. 1 tick mark. Come on. There we go. Alright. So we have that the angles of that middle triangle are the same, but what about the sides? Well, I can show that triangle CDE is congruent with triangle CDE must be congruent with the triangle DBF because we have angle, side, angle, angle, side, angle. So we have DBF. So I know those two are the same, which means that this side FB is going to match with ED, so that has the 3 tick marks. Now similarly, I can show that triangle, I'll use CDE again, or CED I'll use to make it a little bit clearer, is congruent, the same as triangle. Well, we have 2 tick marks, 1 tick mark angle, and then 3 tick marks. And if I look at EAF, 2 tick marks, 1 tick mark angle, 3 tick marks, then we would have side angle side. So EAF. by side angle side. Okay. Now, how about... Well, we have those two, and if these two are true, then that means that triangle DBF is also congruent to triangle. Since they're both congruent to CED, then DBF has to be congruent to EFA. And you can use pretty much any congruence property you want at that point. So, we know, now we just have to show that this last one in the middle is congruent. So, if EAF is congruent with CED, CD is going to match with EF, so this has a 1 tick mark. And this side will have the 2 tick marks, and like it should be pretty obvious. I mean, we have a million different ways to prove it at this point that triangle EDF is congruent to triangle, I mean to all of them really, but I'll just say EDF and DEC. And that implies that they all are equal to each other, since, you know, they're all congruent to that same CED or DEC or whatever. They must all be congruent with each other. And that proves what we were looking for. We have that all the triangles are similar. Oh, I missed out DEF similarity statement. It would just be angle at that point, since we showed all the angles are the same. Hopefully that's pretty obvious. But now all this leads to a fairly important theorem called the Midline Theorem. So, given that triangle DEF is the medial triangle of ABC, we have that DEF is similar to ABC, DEF is congruent to FBD, which is congruent to AFE, which is congruent to EDC. We also have that EF over BC equals DE over AB equals DF over AC equals 1/2. Well, where did that come from? Well, it's just the fact that when we were doing those ratios in the previous part, all those ratios would end up being equal to 2, or specifically like 2/1. So they all have that 2-to-1 ratio. I just didn't do it for every single one of them because it would be very tedious. But they all have that 2-to-1 ratio or 1-to-2 ratio. It's the same basic gist. And because of those, because of all that congruent angles, all the congruent angles we found, we know that ED and AB are parallel, EF and CB are parallel, and what's the last one I missed? EFBC, DEAB, blah, blah, blah. All those points come together to form the Midline Theorem, which is a really, really, really excellent theorem that can make a lot of problems very simple to solve.